Sciencey, we do best. Miss C helps you pass the test. Whee!
Hello and welcome to the How To series of science videos with me, Miss C. In these videos, we will tackle the topics which at the moment make your brain hurt and make them less painful. In this video, we will focus on how to calculate enthalpy changes in chemical reactions. What do we mean by enthalpy? Well, heat energy or enthalpy is the change in the amount of heat as a result of a chemical reaction, such as combustion or neutralization. How do we do this? Well, guess what? We've got a little nifty equation that we can use. You may have already seen this equation and be familiar with it. Heat energy change is equal to the mass times the specific heat capacity times the temperature change. And the units are heat energy is measured in joules, the mass is measured in grams, and the specific heat capacity is measured in joules per gram per degrees Celsius, and the temperature is measured in degrees Celsius. So let's have a look at a worked example. Now this example is of a neutralization reaction. And before we get stuck into this, there are a number of steps involved in solving these kind of calculations, and the number of steps depends on how much information you're given in the question. Now, if we looked at this worked example, we can see that we're given quite a lot of information in the question. So we've got 25 centimetres cubed of 2 moles per decimetres cubed of sodium hydroxide solution is neutralised in a titration by 28 centimetres cubed of hydrochloric acid. The maximum temperature reached in the reaction was 31.8 degrees C and the initial temperature was 19.3 degrees C. Calculate the enthalpy change for the neutralisation reaction. How do we do this? So first we've got to work out the total volume of the solution in the reaction. Secondly, there are a couple of assumptions that we need to make. Firstly, that the density of the reaction mixture is the same as that of water. So 1 centimetre cubed of the solution has a mass of 1 gram. The other assumption that we need to make is that the specific heat capacity of the mixture is the same as that of water. And this is a fairly reasonable assumption to make because the neutralisation solution is mostly water. Okay, next, all we do is substitute the data we've got into the equation. And then we've got to work out how much heat is released when 1 mole of alkali reacts with 1 mole of acid. And this is called the molar enthalpy change of neutralisation. So to do that, first we've got to work out the number of moles of alkali. And what we need to remember is that the moles of acid will be equal to the number of moles of alkali because the temperature was taken at the neutralisation point. Very important point for you to remember. And then the last part of that is we've got to substitute our values into the molar enthalpy change of neutralisation equation. So there you can see delta H equals the heat energy change divided by the number of moles of alkali or acid reacted. Okay, so that sounds like a lot. Let's have a look at that example to see how it works. Now, with this particular question, we only actually need to carry out the last couple of steps because, as I said, we got given quite a lot of information in the question, so we've got very little calculating to do. So we need to just jump to step 4.1. So we've got to calculate the number of moles of alkali. And we've already said that the number of moles of acid will be the same because the temperature was taken at the neutralisation point. So we've got the moles of potassium hydroxide. So to find that out, all we do is multiply the concentration by the volume. So in the question, we were given a value of 2 moles per decimetre cubed and a volume of 25 centimetres cubed. So remember, to convert centimetres cubed into decimetres cubed, you divide by 1,000. When you do that, you end up with a volume of 0.0500 moles. So now we can substitute all the values we've got into the molar enthalpy change of neutralisation equation. And here we have it. So we've got our heat energy change divided by the number of moles of alkali reacted. And here we've got the amount of heat released in the neutralisation reaction when 1 mole of potassium hydroxide reacts with 1 mole of hydrochloric acid. Now you can see that there's a minus sign in front of the value, 55.4 kilojoules per mole. And the minus sign tells you that heat is released from this reaction, which means it's an exothermic reaction. So let's have a look at another worked example. So we've got a student investigating the amount of heat given out by hexane when it burns. And imagine that you're doing this in your lab yourself, and this is your table of results. So when you've got your results table, it's very easy for you to see your data that you're going to use in your calculation. So we've got to calculate the amount of heat energy released when hexane undergoes combustion, and we're given the value for the specific heat capacity of water, and we're also given the value for the density of water. Next, we're going to calculate the amount of heat energy released per gram of hexane. So let's do this. We're going to substitute the data that we've got in our table into the equation. So the mass of water is 100 grams, the temperature change, we work it out to be 36 degrees C, and we're told the value for the specific heat capacity of water. Stick those numbers into the equation, and we end up with a heat energy change of 15.0 kilojoules to 3 significant figures. So you've always got to make sure you check how many figures you've got to quote your answer to, because there will be marks for it. Now, let's work out the mass of hexane burnt. So we can do that using the values that we've got in our table, and we find out that it's 0.39 grams. To work out how much heat is evolved per gram, all we do is divide our value that we got in the previous equation by 0.39 grams, by the mass that you've just worked out of how much hexane was burnt. And then we've got a value of 38.6 kilojoules per gram. And again, the answer's been quoted to 3 significant figures. The combustion reaction is an exothermic reaction, so you need to make sure that you've got a minus sign in front of your answer. Okay? So in this case, the heat energy released per gram is minus 38.6 kilojoules per gram. And voila, you've actually done it. Well done. So, I hope you found this video useful. Go back and replay it as many times as you like, work your way through the examples again, and then go off and answer your own examples. I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you'll be notified when more videos are added. If there are any other calculations in biology, chemistry or physics which make your head hurt, please add them to the comments box, and you may say your request being turned into a video very soon.
All things sciencey, we do best. Missy helps you pass the test. Whee!